the sense, this item is just a kind of review of chapter 3 that we have. And if you remember in chapter 3, we told you that the empirical rule is basically tell you that if we have a bell-shaped curve, and the middle, which is, this is our bell-shaped curve, and the middle of this bell-shaped curve, which is the highest peak of your curve, this will be your mean, and your mean, your median, and your mode. And looking at this thing here, they just tell you that if you within one standard deviation, meaning if you go above 1 and below 1, which is -1 and +1, it will consider 68% of your data, right? 34 on the left and 34 on the right, they are symmetric. And that's the unique thing about a normal bell shape or a normal curve, is they will always be symmetric, and it will always be this curve. So it's not, it's still your one of your probability density curve. It's just that this is a normal standard curve. Okay. And the other one is if we go 2 standard deviation above and 2 standard deviation below, we will consider 95% of the data, or the area underneath this curve will be 95%. And if you remember, lastly, if we go up 3 or within 3 standard deviation, last time in chapter 3, we say almost all of your data. Now we know that exactly 99.7% of your data. Okay. And the idea of this bell-shaped curve is, ladies and gentlemen, is no matter what data you have, okay, the idea is no matter what data you have, whatever data that you collect, for instance, you collect the height of your student, you collect the weight, you collect the age, you collect the distance that you travel from each student house to the campus. So no matter what data that you try to collect, the idea is if you collect enough data, if you collect a lot of data, I should say, a lot of data, is will tentatively turn out to be this symmetrical shape. Okay, so if you know, and I mentioned this earlier in chapter 3, is if I have a quarter and I flip this quarter, what is the probability of me get a tail? You would say, well, 50%, right? 1 out of 2. But like I mentioned, if I flip 10 times, will it come out to be 5 head and 5 tail? You probably say, yes, can, but it's not always, right? So basically, if we flip 1,000,000 and 1,000,000 times, like million, 10 million, 100 million times, right? If you flip a lot of time, eventually it will come out to that true probability, which is 50-50. Okay, so in the same idea, if you collect a lot of data, your data, if you collect a lot of data, the idea is your data will tentatively come out to be this curve. So whatever your density curve is, if your density curve, if you collect like 2 data and it's skewed to the left, like all of them is do good on the test, right? 2 students do very good, both of them pass the test, and 99 and 100, right? Meaning your data is just skewed to the left. But if you collect, if you have 10, it start to spread out and spread out. And if you have like 1,000,000 people took the same test, then it will eventually come out to be something like this bell-shaped curve. Okay, and that's the idea of this bell-shaped curve. So now, one thing that we will use about this bell-shaped curve is, one thing that we know about this bell-shaped curve is if we mention that we have a standard normal distribution or bell-shaped curve, my mean will be 0 and my standard deviation will be 1. Okay, and again, basically your mean is the center peak of your curve, and your standard deviation is spread out as in 1. Okay, and if you remember in chapter 3, your z-score tell you how far away from the mean, right? How far away are you from the mean? And if the z-score is positive, we know that we are above the mean, or in this case, you are on the right of the mean. In terms that positive, you are on the right of the 0. And if you have a negative z-score, meaning you below the mean, or in this case, you are on the left of the zero, because negative number is on the left of zero. So in the same idea, all you're doing is we try to find whatever your data is, whatever your x value is. If you collect the height is the x value, you can convert to the z-score, which is the standard normal. And again, the standard normal for any data, if you convert them to a standard normal, then it's come out to be this bell-shaped curve. And that's our goal. Is the ideal data is this bell-shaped curve, right? The average, a lot of people is cluttered around the average, and the further away the average, the less and less people. The further away the average, and less people. And ideally, we have, balance them 50% above and 50% below. Okay, so our goal, as mentioned in last semester, not semester, last lecture, is we try to find the area underneath the curve. And with this standard normal, we still can find the area underneath the curve. And if you remember in chapter 3, we are restricted, right? We can only go above 1 and below 1, above 2 and below 2, above 3 and below 3. Now we are more a little bit advanced, and we ask you find the area underneath the standard curve where the z-score is 2.56. In chapter 3, we cannot do this. We cannot find the area, right? We cannot find the percentage using the empirical rule. We cannot find the percentage of the z-score of this item here, right? So there are two ways of doing this thing here. I want to introduce you to this table first. So they tell you that doing this table, or if you look at this table here, give me 1 second. If you look at this table here, this is your normal standard deviation, or your normal, your standard normal cumulative item. So one thing to utilize this table, whatever the value inside the table right here, this is the percentage of your data. And the percentage of your data, whatever this value, for instance, if we were to looking for this value here, 0.6293, that is the area underneath your curve from the left-hand side to the given z-score. So what is this z-score? Well, this z-score is 0.33. So up here, this is your 100th position, the 100th position, and this is your z-score of the 1 position and the 10th position. So as you can see right here, this is 1, right? 1.00, meaning this is 1, 1.01, 1.02, 1.03. And this is 0.03, 0.031, sorry, 0.30, 0.31, 0.32, and 0.33. Or as you can see, if we clear all this thing here, and if you look at this value, right here, what is 0.5? Again, the z-score is 0. As you can see, the z-score is 0, meaning that is your mean, which is at the middle. If you z-score is 0, you at the mean, which is you of 50% of the data is on the left of that z-score. So in this case, in this problem, or given this table, we can find the area to the left. And this table is only restricted to the area accumulation to the left, from the left-hand side to the given z-score. So that's good, right? That's all we needed for this problem here. If we go back to this problem, this is what they asked us to do, is they asked us to find the area to the left of the z-score of this. So before we can attack this problem, I want to advise you guys, and I want you guys to do this all the time from here on out, is whenever they ask you to find this area, or to find the probability, or to find the proportion, sketch your standard normal, right? It doesn't have to be perfect. It's just, you just sketch this thing here, and then you can see that if you sketch this thing here, you can see that if you're looking for the area to the left. So let's say that this number right here, This number right here is 2.56, right? So let's say that this is my number. My number right here, my z-score is 2.56. And now, do you agree that they asked me to find the area to the left? The area to the left meaning whatever from here to this given point. That's what I'm looking for. Is I'm looking for the area to the left of that, right? So this is what I want you, and hopefully that you will do. And from here on out is basically sketch your standard normal and shade the region you're looking for. You shade it to the left if they ask you to the left. You shade it to the right if they ask you to the right, and you shade it in the middle if they ask you in between. Okay, so in this case, this is what we have. And now, how would we go and find this answer? If you look at this thing here, 0.9948, how would we go and find that? Well, we just basically looking at our table. And because they asked us our table, they asked us for 2.56. We know that this thing here is on the right hand side. So let me zoom in. Right, well, that's too much. Let me zoom in, and because we're looking for on positive, so you can see that over here is negative value and over here is positive value. So we go to the positive value and we go to 2.5. As you can see, 2.5 is right here. So this is my column 2.5. And those are my column 2.5. And then I have to go to the 6, which is 2.5, the 6, which is the 100%. So 2.56 is right here. And as you can see, my answer earlier is 0.9948. So that is where 2.56. If they ask you for 2.59, 2.59 will be 0.9952 because again, 2.95, okay, 2.59. Okay, so that's the idea of this table. This item is your 1 position and your 10th position. This item up here, this is your 100th position, meaning again, 1.1, 1.11 is right here, 1.11. Okay, so that is what you need to do to utilize this table. All you need to do is ask yourself, what is your first 2 position, the 1 position and the 10th position, and then you go up to the 100th column, which is again the 0.01, the 0.02, and so on and so forth. Okay, so again, same idea. If they ask you for find the area to the left hand side of negative 0.53, and again, if you sketch this item out, we know that negative 0 is somewhere here. Negative, it doesn't have to be precise, but this is the area we're looking for, right? We're looking for the area from the left hand side to this point, to this value, right? So that's what we have. And if you're looking for the area to the left, life is easy. Why life is easy? Because the table can give you the answer, right? So negative 0.53. So negative 0.53, we just go into this item here. We go into this item, and because we deal with a negative, we go over here. And negative 0.53, we go down to 0.05 or 0.5, right? This is my 0.5. And then they asked me to find the negative 0.53, right? 0.53. So I know that looking at this item here, I know that this is 0.5, 0.50, 0.51, 0.52, 0.53 should be this number right here, which is 0.2981. Okay, so this is how you utilize, this is how you get or to use your table. So first of all, question with this table here, and this table you can use this, it will be there for you on your exam and on your homework, and your quiz is there. Okay, so this is 0.53, which is 0.2981. So one thing is, The other thing, if you don't utilize your table, and your table is restricted too, right? Your table is restricted in the way that it can only be those number, right? If it's something, if they give you 3 decimal place, if they give you like 2.567, you guys cannot do it, right? If they give you 2.713, you cannot do it. Your table is only limited to 2 decimal place. And now, beside the table, our calculator can help us to find this area. And your calculator, if you remember in chapter 5, we're using binom PDF and binom CDF. So one thing I want to point out to you guys is we will never, ever use a normal PDF. So on your calculator, if you hit the second var, which is that's where you look at for the binomial, we will never use a normal PDF. So write a note somewhere, write something and say that we will never ever use in the normal PDF. So again, the only thing we're using is the normal CDF and the inverse norm, which is at the end of this chapter, you will see. But for now, to find the area, we're looking for a cumulative item. So we're looking for the normal CDF. That's the only thing that we're using is the normal CDF. So again, in chapter 5, when we do the binomial distribution and when you find the probability of the exact value for the binomial distribution or binomial probability, we do the binomial PDF. And if we're looking for cumulative item, we're using the binomial CDF. Similarly, over here, we're only using the cumulative item for the normal, okay? So there are 4 items. There are 4 items that you will need for your normal CDF, which is the first item will be your lower limit, the second item will be your upper limit, and then the third item will be your mean, and then your standard deviation. One thing is if it's a standard normal, your mean will be 0 and your standard deviation will be 1. Okay. If they tell you that find the standard normal and they don't give you the mean and standard deviation, they say the normal standard curve, it will be the 0 as your mean and the standard deviation will be 1. Okay. So the other item that we have, the problem we have in your calculator is when you find the area, this thing here, the bell-shaped curve, is look like it's touched the axis, but it really does not touch the axis. It's keep on going and going and going and going. And same thing going to the left and going to the right. So your endpoint sometime, or your endpoint is basically because it's keep on going, is go all the way to negative infinity and go all the way to positive infinity. Your calculator does not have a negative infinity and positive infinity. To make it a little bit easier, on the left hand side, if they go to negative infinity, we will say negative 1,000,000. And on the right hand side, when they go positive infinity, we will say positive 1,000,000. Okay, so those are your, instead of using infinity symbol, we're using negative 1,000,000. Some humongous number is fine, negative 1,000,000. I just pick a number to choose. No, if you put negative, if you put in negative 10 million, is not wrong either. If it's a standard normal, anything after 4 is very small. The probability that after 4 or below negative 4 is very small. But let's take a look at this thing here. Let's take a look at this item. They ask you to find, like I mentioned, they ask you to find the area underneath the standard normal curve. And the standard normal curve, like I mentioned, anything about standard normal, your mean will be 0 and your standard deviation will be 1. Okay, so to do this thing here, like I mentioned, this is what I advise you guys to do, is sketch your item. Because they ask us in between, do you agree that, let's say that this is my negative 0.75 and this over here is 1 0.70. And this is what they ask you to do, is find the area in between negative 0.75 and 1.70, which is this item in between. So if it's in between, it's easy, ladies and gentlemen, because if it's in between, all you need to do is using your calculator. And let me do the 83 first. Whoever have 83 is a little bit difficult than 84. So whoever have 83, this is what you guys need to do, is basically, again, you hit second var. And then, like I said, we will never use a normal PDF. So the second option, normal CDF, is our item. So we choose a normal CDF. Again, to do that, you hit second VARS, second var, and then normal CDF. And all you need to do, because they ask you for the area between the two values, so your lower limit, what is my lower limit? My lower limit will be negative 0.75, comma, the comma is right here on top of number 7, there's a comma, you hit comma, 1.70 is my upper limit, comma, the standard deviation, because it's a standard normal, is 0. I mean, the mean, because it's standard normal, the mean is 0, and the standard deviation is 1. And then you can just close the parenthesis. And again, the reason why I say TI-83 user is harder, because you have to manually type it in. And if you manually type it in like this, all you need to do is press enter, and this is what you should have, is 0.7288. Okay, so again, and the idea of the sketching, your item is to show you what is your lower limit, because as you can see, the area, the shaded region I have is between negative 0.75 and 1.7. So in terms of this thing here, the area is in that region, is tell me that the lower limit and the upper limit. Okay. And similarly, if I ask you for the area to the right, if I'm asking you for the area to the right, do you agree? Or if you look at this thing here, this is what I have, is, let's say that this is my 2.04. It doesn't have to be exact, right? It doesn't have to be exact, but I know that between, like at the peak right here is that 0. So anything positive will be on the right, but it doesn't have to be exactly precisely in that number. The idea is we're looking for the area to the right, which is the shaded area to the right. So if you're looking for the area to the right, everybody see that this 2.04 is my lower limit. And this thing keep on going to the right, going. What would be my upper limit? Well, if this thing is keep on going, somewhere right here is going to be positive infinity. And again, our calculator, we cannot use positive infinity. So our upper limit, we will use 1 million. Okay, so that's the idea of the shaded region. The shaded region tell me, right? The idea of the shaded region tell me to identify my endpoint. I can identify my endpoint in terms of the lower limit. So looking at this thing here, to find the area to the right of 2.04, all I need to do is hit second. Let me clear this so you know. Second var, go down to normal CDF. And then again, what would be my lower limit? My lower limit, as you can see, the first number I see is 2.04, or the first item I have is 2.04. And then my comma, what is my upper limit? Well, my upper limit, because it keep on going, it will be some humongous number. So let me just put 1 million, right? 1 million, comma. Again, it doesn't have to be 1 million. You can use 10,000 is fine. 10 million is fine. What is my mean? My mean is 0. And what is my standard deviation? My standard deviation is 1. It's just because it's a standard normal, your mean is 0 and your standard deviation is 1. And then if you press that in, this is what you guys should have, which is 0.0207, right? If they ask you for 4 decimal place. So in the SAM, this is what you type it in. And again, 1,000,001, and your answer should be 0.0207. And similarly, you know, I know if you guys have questions, bear with me here. Let me take a look at this, take a look at this problem. And similarly, they ask you this thing here. They ask you to find the area to the left of 1.01. And again, we can use the chart, but looking at this thing here, do you agree that we're looking for the area to the left? We shaded the area to the left of 1.01. And given that, we know that somewhere along right here, somewhere along this region, we have some smaller limit. Because we have something on the left, our slower limit will be a negative infinity. We don't have negative infinity, so we will use a negative 1,000,000. Okay, so again, that's the idea of sketching. The idea of sketching is show you, hopefully give you the idea of, are we using the lower limit as in negative infinity, or are we using the upper limit as in positive infinity? And again, let me change it to, for those of you who are TI-84 user. Again, the reason why I say TI-84 user have an easier method than TI-83 is they give you the prompt, right? They give you the prompt. They tell you lower limit. This is what your book and your calculator or your Connect Math tell you to do is, for your lower limit, you put in -1 E99 is basically tell you is some humongous number. You have 99 decimal after this one, right? Which is, that's the E, the second right here. Instead of doing that, just put in negative. Instead of doing that, just put in negative million is fine. You don't have to need to be that much. So again, my lower limit based on this thing here, because I'm looking for the area to the left, my lower limit is somewhere over here, which is negative number. And then my upper limit would be the maximum number I have, in this case, 1.01. And then my mu, which is my mean, is 0, and my standard deviation is 1. And then again, your 84, they have that prompt, you press it in, they wrote it out for you instead of you manually type like 83. And then you just press enter, they should give you the answer, which is 0.8438. Okay, so this is what we type in, and this is what you should have, 0.8438. So here, question, let me ask you guys, question in terms of where, question between A, B, or C here. Any question on how to utilize your calculator to find this answer that we have here? And one thing is, I did not focus a lot in terms of the table, because the table, the only thing that the table give you is the area to the left. So if they give you the area to the left, the answer is in the table, right? And if they ask you for the area to the right, well, whatever the answer you find on the table, you have to subtract that from 1, because again, the maximum total area underneath the curve is 1. And if they give you the left and you're looking for the right, you need to take that, subtract from 1, right? And if you're looking for in between, you have to look at this item and minus this item in terms of the area. So instead of doing that, your calculator can help you, save you some time. Okay, so one thing is, that is the idea of this 6.1. The core idea is, if we have a z-score, we can find the area, we can find the percentage, we can find the probability, we can find the proportion. Now, what if they don't give you a standard normal and they give you something like this, right? And this is what you want to do, is you want to take the same idea. You want to use what idea you learned in example 4 to apply in example 5, right? So this is what they tell you is a normal population. So one thing is, you need to have this. Without this, we cannot use in our normal CDF. The reason is, we need to know that our data is normal. If our data is not normal, meaning you have some probability density curve. Reminder, the probability density curve is just basically tell you that you have some curve. It can be skewed to the left, skewed to the right, or it's not symmetric. So they have to tell you that your data is normal. Okay, so if we know that our data is normal, meaning it's a bell-shaped curve, they give us the mean and they give us the standard deviation. And ladies and gentlemen, this is the two most important thing that you need in chapter 6 is without the mean, without the standard deviation, you cannot find the area underneath your curve. You cannot find anything without the mean and without the standard deviation. Okay, so now this is what they ask you is what proportion of the population is less than 20? So do you agree that less than 20 is something like this? So this is, let's say that this is my sketch. My sketch of my graph is this item. And instead of last time 1.01, now I say that this is 20. Do you agree that any number on the left of 20 is less than 20? So looking at this thing here, this is what I'm looking for. I'm looking for the area to the left of 20, right? So it's the same idea, the same concept as this thing here. And if you remember, I told you guys last time, the area underneath the curve, the proportion, and the next thing you will see is all the same, which is the next thing you will see is the probability. So if they ask you the area, if they ask you for proportion, or in the next problem, they ask you for probability, it's all the same thing. So if we know that we're looking for the area to the left because it's less than to the left of 20, all you need to do is now you can see that your calculator can do the rest. Well, you have to tell your calculator to do the rest, right? So if you type it in your calculator, what do we have? Well, we have to hit second VARS, and then we go to the normal CDF. And again, for this item, we know that the lower limit will be some negative number, some negative humongous number. And my upper limit will be 20 because that is my new item. And they give us the mu, which is my data is 9. And they give us the standard deviation, the population standard deviation, the sigma, the Canon looking item, right, is 6. And then all you need to do is you type in those data and then you press enter and enter. So looking at this thing here, your probability or your proportional is 0.96666, right? So if you type this in like this, this is what you have. Normal CDF and lower limit, upper limit, your mean and your standard deviation. And like I mentioned to you guys, right? Don't let the wording, because that's what you will get, or that's what a lot of you guys will stumble on is, wait, what am I looking for? Remember, I mentioned this item to you guys, right? Proportion, probability, and the area. Those three items is just the same. Okay. Don't let the wording make you stumble and forget what you're looking for. Okay, so we're looking for the probability that a random choosing variable value will be between 7 and 13. So between 7 and 13, do you agree that this is what we have, right? Go back to my between sketching. So looking at this thing here, you don't have to if you can see it, but again, this is the idea, right? The idea is we have 7 here and 13 over here. This is the idea is, again, we know that if we sketching out, do you agree that my lower limit is 7, my upper limit is 13? We're looking for in between. There's no sugarcoat in between, right? So this is what we have. We're looking for area in between. And again, we know that my lower limit will be 7, my upper limit will be 13. My mean is 9, and my standard deviation is 6. If I type it in, this is what we have, 0.3781. So looking at this slide that I have for you guys here, first of all, anyone does not have the answer I have here, or anyone does not know how to utilize your calculator to find the answer here. Question? So all of you know how to utilize your calculator and type it in and find this answer. And you will see, ladies and gentlemen, the map. You know, I keep on saying it, and probably by now you say it's just The math in this in this class is not hard because your calculator, took the heavy loading for you guys, right? The calculator took the heavy loading for you guys. The problem is, how can you tell your calculator to do the heavy lifting, right? You don't need to, if you were to do this by hand, without a calculator, you have to convert to the z-score, and from the z-score you have to look at the table, and from table you have to either subtract from one, subtract from each other, or just take it as it is. Okay, but again, let's take a look at this item and see. This, for me, this is how I were to attack this problem. Doesn't matter what the data is. First of all, we know that it's a normal population, have the mean and the standard deviation. So that's what we have. We need a mean, we need a standard deviation. Now, what do they ask us? They ask us, what is the proportion of the population is greater than 100? What does it mean, greater than 100? Well, sketch your standard normal or bell-shaped curve, right? Standard normal curve or bell-shaped curve. So do you agree that greater than 100 is anything to the right of 100? And that's my orange item, right? And again, it doesn't have to be like this, right? For you, because it's sketching, if you want to, you can say, well, my 100, kind of is not like, it's not this much, but if you want to, you can just sketch it right here and just say, well, I'm looking for the area to the right of 100, right? It just gives you the idea. Why do we sketch it? It gives us the idea of what is our endpoint. As you can see, this blue line is not precisely correct, right? Because the mean is 61, and that's where this 61 is, right? 100 is bigger than 61. Remember, what is the mean? The mean is the middle of the line, right? But again, we sketching it. I don't grade on your sketch, right? I don't grade on how cleanness the sketch is or how precise the sketch is, right? So looking at this thing here, precisely 100 somewhere here, we're looking for something greater than, which is this item. So we know that looking at this thing here, the lower limit will be 100, and the upper limit will be some humongous number, will be in 1 million. And then my mean, what is my mean? My mean will be 61, and my standard deviation will be 16. So everybody see that those are the 4 items we need. We're looking for a proportion, the probability or the area is the same. Normal CDF 100 is my lower limit. In this case, in this one here, I put 10 million, but it doesn't matter if you put 10 million or a million. And again, it depends on your data. Your data is only 61, 10 million is fine. And everything is like that. And if you type it in your calculator, hopefully all of you guys have 0.074 if they ask you for 4 decimal place. Anybody did not have this 0.0074. Same idea, right? Same concept. What is the probability of a random choosing value less than 81? Again, probability is the same as proportion, and less than, do you agree that less than is something on the left-hand side? And because of this thing here tell me 2 things. Is tell me that what is my lower limit, because I'm looking for a left or less than item. My lower limit, my starting lower limit will be some negative humongous number, and my upper limit will be this. Okay, last time my lower limit is 100 and my upper limit is some humongous number, right? So that's the idea of the sketching, right? The sketching is not to make the problem look nicer, it's to tell you where is your lower limit and where is your upper limit. My lower limit is some negative humongous number, in this case, negative 1 million. My upper limit, the last item I have is 80. My mu is still 61, and my standard deviation is 16. And again, if you type it in, you will get 0.8825. And lastly, in between, no sugarcoating, in between, it's just like that. It's just the way that they say it. In between, we're looking for the area in between. And again, looking at this thing here, I know my lower limit is 59. and my upper limit is 72. And look at the thing here, all I need to do is type in normal CDF. 59 is the lower limit, 72 is the upper limit, and the mu is 61, and the standard deviation is 16. And again, if you type it in, hopefully you guys have 3039, 0.3039. So question with this thing here, question with, if we give you, again, this thing here, they give you the mean and they give you the standard deviation. If they say a standard normal, then the mu is 0 and the standard deviation is 1. Okay. So question with this particular problem here, ladies and gentlemen. Pretty doable, I hope. Now, if you don't have question, they changing the script on you guys, right?
Mr. China,
So just like before, yes.
I have a question.
Go ahead.
When I was doing like the homework for it, I used the tool to help or whatever, and it said they did like -1 E99. Is that equivalent to that 1 million?
Yeah. The negative E99 is basically tell you that -1 with 99 0 at the end of it. So that's that, like, is a lot, like it's very small. So yes, instead of writing E99, we just using -1 million. So it is equivalent, it's the same.
Okay, thank you.
Yeah. So that's why I say, like, instead of using the E, we just say use some humongous number. -1 million or -10 million is fine. But because if you want to type in E99, you have to hit, because the reason I did not do that, because if you type in E99, you have to hit second this item right here, which is the blue E right here, and you put in 99. So if you put that, that's what you type in. So, you know, instead of do that, we just say, it's basically tell you that there's 99 0 after the 1. So that's the E stand for. So -1 million or 1 million is equivalent. Not really equivalent, but for our problem is work the same. Okay, is 1 million is not equivalent to 99 0 after the 1, right? That's some humongous number. But again, is for our purpose of our math is the same. So the next thing, or the last thing we have, is now they changing the script on you guys, right? Last time on the previous example, they asked you to find the area underneath the curve. What happened if they change the script and they give you the area and they ask you what the z-score is, right? So in this case, this is what they tell you is, if I got the 26% right here, if I have the 26% right here, what will be the corresponding z-score? Or what will be the corresponding data, right? How would we do that if we have the percentage? So in terms of this thing here, and this is where the table is confusing. This is where the table is a little bit confusing in terms of this method. So instead of focus on table, your calculator can do this item for you, which, like I mentioned, the only two features we deal with the normal is the normal CDF and the inverse norm. So the inverse norm, which is the inverse normal, is basically tell you that, oh, I have this percentage. Now I want to find the data. Can you give me the data back? Can you give me the z-score back? Okay, so the inverse norm is this item here, but the restriction of the inverse norm, ladies and gentlemen, if you have a more advanced calculator, you can get by with it. But my calculator, the TI-83 and the 84 that I have here, cannot find the area to the right. So the inverse norm, this is what you guys need, is you guys need 3 values. The 3 value that you guys need is you guys need the area to the left of that given value, the mu, which is the mean, and the sigma, which is the standard deviation. So for instance, if you were to, or if they were to ask you to find this item here, If they were to ask you to find this item here, this is what you need to do is you need to hit second var. Instead of use the normal CDF, we have to go inverse norm, which is option number 3. So you press enter, and this is what they ask you to do, or this is what they have is the area to the left. Reminder is only the area to the left, which is 0.26 comma, no, not comma. This one here doesn't have a comma. 0.26. And then the mu for us, for mu, because it's a standard normal is 0. And again, the standard deviation is 1. And again, this will give us negative 0.6433. So the z-score will be negative 0.6433. Okay. So before I continue, anybody using the TI-83? Anybody have TI-83? Okay.
Yes.
Since you have the TI-83, my other section doesn't have any TI-83. But again,
I have a question. The one I'm on, when I do it, it asks me, it has all of that, but then it asks me where I want the tail to be.
so you have the advanced one. Basically is tell you that is it to the left, is it to the right. So you have to, you have to type it to the left if it's to the left, or if it's to the right, you have to type it to the right. So if you have the advanced one, they tell you it's a tail is to the left or to the right. So you have to know what percentage they give you. Is it the percentage to the left, or is the percentage to the right? Okay.
How do I know?
Well, you look at your sketch. Right here. This is the area you shaded, which is on the left-hand side, right? If you look at this sketch right here, where did you shade it? Do what?
To the left.
To the left, right? So that's your left tail, right?
All right, thank you.
So for 83 user, again, for you guys, you have to manually type in the 3 value. And the 3 value you have is, again, we need an area to the left, which in this case, my area to the left is 0.26. You need to manually type in comma, the mu, which is in this case, the mu is 0, comma, and the standard deviation is 1. So you have to manually type the 3 value here. And if you type it in, and you should get the same value as the prior one, which is negative 0.6433. And we know that it's some negative number, right? We know that if this is remember this right here, in the center of this table is 0, right? In the center of this table, remember what is the z-score here? The z-score here is 0.00. And if it's 0.00, meaning 50% on the left and 50% on the right. But this thing here, this is not 50%. This is only 26%, right? 0.26 is 26%. So we know it have to be less than 0. And if it's less than 0, meaning it's negative number, right? That's the idea. But again, looking at this thing here, this is what you guys need to ask yourself. And that's where I ask you guys to sketch your item. And again, for whoever mentioned the left or the right, you can skip this step here. If your calculator, if you have an advanced calculator, you can skip this thing here. You can tell them it's on the right or on the left. But for those of you who are like my calculator, this is what you need to ask yourself. The first step is, for every question, is you want to sketch your normal curve. And then you list what area do they give us. Do they give us to the left, or did they give us to the right? If they give us to the left, we got it, right? This one here, if they give us to the left, we just type it in, right? If they give us the item to the right, this is what you need to do is, if they give us the item to the right, do you agree that I need to take 1 minus the item to the right? Because the total item is 1, right? 100%. And if they give us the item to the right and I'm looking for the item to the left, I need to take 1 minus this thing here so that I can have the area to the left. Okay, so in the sense, once you identify the area, because those are the three things you needed. You need the area, you need a mean, and you need a standard deviation. Okay, so if you ask yourself, or if you do this problem here, example 6, and they ask you find the z-score for which the area to its left is 0.313. So what does it mean, the area to its left? So again, we're looking for, like I mentioned, we sketched this normal curve, and we know that this is my item right here, right? And the area to the left, which is this item right here to the left of this z-score, right? We're looking for the z-score. I don't know what this z-score is, but I know the area to the left is 0.13. Agree? So if it's 0.13, which they tell you the area to the left, so now I know that because it's an area to the left, I'm good to go. All I need to do is type in my inverse norm. And again, because they asked us for the z-score, I need to use the inverse norm, or because they give us the area, we will use the inverse norm. And our inverse norm, we will say 0.13, comma 0, comma 1. And again, that's all you need to do, all you need to type in. And in this case, you have a negative 1.26, or depend on how many decimal they want it to be. So again, this is what you type in, and this is what you should have. If they wanted 2 decimal place, you give them 2 decimal place. If they want 3 decimal place, you give them 3 decimal place. Okay, and this, ladies and gentlemen, this is where the chart is painful. It is very painful if you were to use a chart. And 10 years ago, when I took this class, I don't have this calculator. My teacher make me use the chart. But again, for you guys is doable, right? So looking at this B, find a z-score. Find a z-score for which the area is to the right is 0.05. So again, the area to the right, because they mentioned this, right? The area to the right, just like they say, the area to the right in this case is 0.05. So if I know the area to the right of this thing here is 0.05, and I'm looking for the z-score, and my calculator, right, can only calculate the area to the left. So everybody see that because my calculator can only calculate the area to the left, that's why I need to take 1, the total area minus the item to the right. And that will give me 0.95. And again, this is what I have. This item right here, the white item is 0.95. And I type in my inverse norm 0.95, comma 0, comma 1. Okay. And whoever say, Mr. Tran, I put in the 0.05 and I have a negative 1.645. Yes, because you basically tell your calculator, if you put in the 0.05, you basically tell your calculator, calculate this right here, which is the 5% on the left. Okay. And remember, this is a normal curve. Your standard normal, they are symmetric, right? And this is only work if this is a standard normal. They are symmetric. It's not work if you have your data. Okay. So before we move on, let me ask you guys, question with A or B, looking at this thing here, how you find the z-score utilizing your calculator, or question of your calculator, how to input in. So if you don't have question, let's take a look at this thing here. And similarly, right? Similarly, this is what the guy will have, or this is what let me I go back to this question. Let me do this question right quick. Not this question. Let me do this question right quick, and I go back to the previous question. So let's take a look at this problem here. Let's say that they put everything together. And like I mentioned to you guys, you have only 2 items, which is the normal CDF is when they ask you to find the area, the probability, or a proportion. If they ask you those three, then you use the normal CDF. If they ask you to find the value or the z-score, then you have to do the inverse norm. Those are the two options that you have. Okay, so let's take a look at this example 7, and they ask you a survey among freshmen at a certain university review that the number of hours studied the week before the final exam were normally distributed. And again, the only reason why they put this normally distributed in here is to show you or to tell you that your data is a bell-shaped curve with the mean. So we know that they give us the mean is 25 hours and the standard deviation is 7 hours. So again, based on this information, they tell you that the freshmen, they 1 week before final exam, they cram it in, they study on average 25 hours the week before the final exam. Okay, so this is what they ask you is what is the probability? What is the probability that a random selected student spend between 15 hours and 30 hours? So we know that because they ask us the probability, do we using the normal CDF or the inverse norm, right? That's what you have to ask yourself when you do all this question is, which one am I doing? The math is easy, but I have to know which one am I using. Because they asked me probability, I have to use the normal CDF because probability is the same as the area underneath the curve, right? Basically, they ask you for the area. So in this case, if you sketch this item out, right? If you sketch in your normal curve, everybody see that between 15 and 30, that's what we have. And if we know that between 15 and 30, and we're looking for the area underneath the curve, all we need to do is we do the normal CDF. 15 is my lower limit, 30 is my upper limit. And again, my mu is 25, my standard deviation is 7. And all I need to do is type it in, and this should give me my percentage, which is the probability will be 0.6859, right? Roughly 68.6% of the student, of the freshman, spent between 15 hours and 30 hours. Okay, so that is the idea of this thing here, the idea of finding the probability. Now, here come the problem, and this is the biggest problem that a lot of you guys will encounter, and you guys will get confused. So we did the inverse norm. And reminder, your calculator, the inverse norm is you can only use in the the left area. So whoever have the advanced one, you can use the in between or in the middle. But again, I don't have that, so I cannot tell you how to maneuver around those. But looking at here, let's dissect this problem. So because they ask you this item here, find the two value. Remember, we are looking for the value, we're looking for the data, we're looking for the z-score, we have to do the inverse norm. Or secondly, if they give you the percentage, we will do the inverse norm because the percentage, which is the area underneath the curve, right? The percentage, which is the proportional. So in terms of this thing here, because they give you this, they ask you between what two value or the middle 80% of the people spent, the 80% of the hours spent studying. So we know that this is what they give us, right? If you sketch it out, the 80% is right here. Everybody see that the 80%, this is my 80%. Those are, that is my 80% of the item, right? So you can see that we have two tail, right? We have this item over here, the missing item over here, and the missing item over here, right? So in the center of this thing here, I'm looking for this two value. I'm looking for this item. I don't know the value. I don't know the hour that they spend that cover 80% of my data. So if I do this thing here, if they give me the 80%, do you agree that I can take 100% minus the 80% that they give me, and that will give me 20% left, right? So I can do this thing here because they give me 80%. I can say, well, the total percentage is 100%. And if I take what they give me, which is the 80%, I have 20% left. But do you agree that 20%, but there are two tail, or there are two-sided, right? It's not just one side. It's not just one item. Because there are two-sided, I need to take this 20% and divide it by 2, right? So 20% divided by 2, do you agree that I have 10% on each side? And that is what you guys need to do, is this item right here. That is your 80% in the middle. And then you have to divide it by 2, which is the leftover, not divided by 2, but the leftover is the 20%. So 100 minus 80 is 20%. And again, therefore, the leftover is 10% on this side and 10% on that side. Okay, so everybody see the concept here. The concept is they don't give us the left side, they don't give us the right side, they give us the middle. And because they give us the middle, I subtract the total, right? Subtract from the total, but I cannot just use 20 because it's not on one side. I have to divide by 2 because they are symmetric. So there will be 10 on the left and 10 on the right. 10 and 10, that's 20. 20 plus the 80 that I originally have in the middle, that will give me 100%. So now, if I have this item, do you agree that I can find this value here? I can find this value on the left-hand side because my calculator can give me the value on the left, or my calculator can calculate the value if I have the percentage on the left. Reminder, you need to type in the decimal. You cannot use in the percentage. You need to convert your percent to decimal, so you use the inverse 0.10. My mu is the same, 25. My standard deviation is 7. So that is my left-hand side, or that's my left value. And now, what would be my right value? My right value is, do you agree that this 10% plus the 80% here? So to find this value, that I need to find right here, I need to type in 90, not just 80, because I need to include the 10 here. So to find this value, the area to the left from here, the area from this item all the way to this item, this is what I'm looking for. The area from the left-hand side to this given value is 90, which is 0.9. 25 is my mean, and 7 is my standard deviation. So therefore, this is what I type in. So the two value that I have is, in this case, this number is 16.03. And this number over here is 33.97. So those are the two value that consider, I erased the one. That is the two value that is considered 80% of my population. The two value that consider 80% of my population is 16.03 and 33.97. Okay. So I know it's the first time you look at this thing here, and we have to analyze it a little bit. Let's take a look at C, and then I will hopefully, after you see C, you can see the idea of this thing here. Same idea, right? Instead of 80%, they ask you for the middle 76. So the middle of 76 is, if you were to sketch this, we know that in the middle is 76. Now, I know, or we need to looking for this area and this area. Because my calculator is still restricted, right? My calculator is not advanced where I can find just the middle. My calculator can only calculate the left-hand side and give me the value. So because question? And because that I need the area to the left-hand side, I need to know what is the leftover. So how do I find the leftover? Well, 100 is the maximum minus the 76 that they give me to give me 24. And if I have 24 and I know that it's not just one group 24, there are two groups. There is one yellow item and there's one white item that is I did not account for. And I know they are symmetric, so I need to take this and divide it evenly. So 24 divided by 2, I have 12, meaning I have 12% on the left-hand side and 12% on the right-hand side to give me my other picture. So give me 1 second. Because again, this thing right here, because I have 12% on the left-hand side, so that's why I use the inverse norm, 12%, 25 is my mean, and 7 is my standard deviation. So I know my value is 16.78. And now to find the area to the, not area, to find the value on the right-hand side, to find this value right here, I know the area is 12 plus the 76, because those are the accumulated area from the left item to this given point. So to find that, instead of using 12, I have to take the 12 plus the 76 to give me 88. And if I do that, or if I type it in, this is what I have in terms of a 33.22. And you can see that this number, 33.22 and 16.78 is smaller. The interval is smaller than 16.03 and 33.997. And again, because they cover 80%, you have to have a bigger interval. And that's what we're going to do interval in terms of the next, in terms of chapter 7. But again, for now, let me ask you guys a question in terms of if they give us the middle, right? If they give us the left, it's easy. If they give us the area to the left, it's easy. If they give us the area to the right, it's easy. We just take 1 minus the area to the right, right? But now they give us the area in the middle. Just reminder, if they give us the area in the middle, we need to take that, subtract from 1, and then divide by 2, because you will always have 2 tail on the left and on the right. Let me ask you a question with the slide that you see on your screen A, B, and C here. Any question? Well, let's pause for today. I'm running low on time.